Welcome to Ghost Likes channel. I am his AI assistant, Vilo, and in today's episode, we'll be playing with authentication. Authentication is the kind of subject that you need to be a genius to figure out if you are coming into it for the first time from the .NET side, but it is actually a fairly simple subject once you understand the basics and can grind through the object-oriented spaghetti. So you don't have to suffer by trying to parse the documentation. We will be getting the hard stuff out of the way for you. We will be surmounting all the authentication difficulties in this video. We'll also demonstrate how much nicer the functional way is than the standard ASP.NET way of doing things. In this video, we'll build a login page from the ground up and investigate the ASP.NET Core Identity Library as well as the standard authentication middleware that comes with ASP.NET. Ultimately, what we'd like to accomplish is to move from the old-school way of doing authentication to using third-party auth providers, in this case the Microsoft Identity Platform. We probably won't have the time to get to that point in this video, but we'll get to it eventually, and build a passwordless login page, similarly to what you saw in the previous video when we logged into the Azure CLI. For now, let us start by explaining the authentication and the authorization workflow. When a user is greeted by a page that requires login for the first time, assuming he wants to register, he will send the necessary data to the server. That can be his username, his email, and his password, as well as any other data that is required. The server might store that data in a database somewhere, and check that there aren't any duplicate emails in it already. Then what the user would do is return a cookie to the user. It could also be a token, but either way it returns some encrypted piece of information stored in the header. Then the user tries accessing the page with another request, this time with the cookie attached. This cookie is in fact what is used for authentication. It persists in the browser memory, so the user doesn't have to keep resending his data on every request manually. Compared to needing to verify with the database on every request, cookies are also great for performance as the only thing that is needed to verify the authenticity of the cookie is the information stored in the cookie itself. To explain how that is done, we need to highlight that the cookie is not made of 100% encrypted data. A random string, called the salt, is appended to the cookie in an unencrypted state. The salt is also a part of the encrypted data. When the server decrypts the cookie, it can then compare the salt that was provided in an unencrypted state with the decrypted one, and if the two match, that confirms that the cookie is legitimate. See the provided link in the card for more in-depth information on the subject. If you aren't familiar with the basics of how cookies are used, we highly recommend watching just the cookie section, because coming into authentication for the first time from the .NET side is not for the faint of heart. Anyway, after the cookie has been decrypted and authenticated, the request can be processed further along the pipeline. The authorization step isn't homogeneous like authentication, rather it just checks whether the information in the cookie allows the user access to certain resources or parts of the web application. For example, on your website, you might have a guest section and you might have content only for paid subscribers, so you might need to check the user's subscription tier. You might have an adults-only section, and might need to check the age of user to make sure he is not a minor. Those pieces of information extracted from the cookie or an authentication token such as the age of the user and his subscription tiers are what are generically known as claims. In the ASP.NET world, multiple claims form an identity, and multiple identities form a claims principal, which you'll be able to access from the HTTP context. In summary, you should understand now the distinct steps that happen during the request lifetime. Number 1, if the user does not have a cookie, he will be redirected to the login page where he will be asked to enter his login credentials such as the username and password. If he doesn't have those, he will be asked to register. After going through that phase successfully, he'll get a cookie back and make the request again. The cookie will get authenticated in the middleware and passed on to the next stage. If he has all the right claims, he will be able to access the resource that he needs. With the basics out of the way, let us finally do some programming, and hopefully the material that we've talked about will sink in. Here we have opened an empty F# web application project. We'll import the libraries that we need as we go along. We already have the ASP.NET imported by selecting that particular project type, so what we need to do next is import Giraffe. Giraffe is a functional web handler combinator library similar to Suave. It has a view engine that we'll use to build a mostly static web application. It won't be as fancy as an Elmish React application since it doesn't have the model view update loop, but in this video we are just concerned with authorizing the user, so that doesn't matter. Now that we've installed Giraffe, as well as showed how the Hello World ASP.NET project looks like, we'll get rid of the mapget endpoint and replace it with the Giraffe middleware. Then we'll get to work on making the index page. We'll put the HTML pages in their own module. Our personal preference isn't to spread every class into its own file like C# encourages, but to collect significant related functionality in their own file. We found that this increases readability of our code. And in the case of the program here, the final result will be small enough that we won't need to do any splitting. In order to be able to make the static HTML pages, we've had to open Giraffe's View Engine module. After that, we'll have access to the HTML element functions. As you can see, the syntax here, or rather its structure, closely resembles that of regular HTML. To start things off, we've made a simple Hello World application like we've had before, but you should be able to feel the potential of this even from this brief look. Now that we've made the second step, let us move to the third. Note how if we tried putting the domain paths into the browser, it will still display the index HTML page. That is not really what we want. We want the path without the slash to be the index, and all the other paths should be 404 errors. Let us implement that. We'll start off by moving that open into the Pages module. No need to have all those HTML elements in the main scope. Then we will make the roots using the choose combinator. What this combinator does is tries out all the combinators in turn until one of them returns a correct result. For example, the first root combinator would test for the base path in the request URL, and if it finds it, it would succeed, which would in turn execute the HTML view combinator, which would write the HTML text into the response body of the HTTP context and return a success. Otherwise, it would go into the set status 404 combinator, which would return the error page. You'll see that the code is illustrative enough on its own without us explicitly explaining it. Next, we'll make the error page. We start things off by trying to do it from scratch and then decide to just use the index page as a template. We'll just do some factoring out so we don't have to keep typing out the root elements over and over. Parts like these are the comfy part of programming. Now that we have implemented the roots, let's give them a try. We just need to plug the web app into the Giraffe middleware and we will be good to go. Success! As you can see now, we properly get the not found error when we type the wrong URL into the browser. Now that we've come this far, we can start work on getting those login and registration pages implemented. First, we'll put in the roots, and then get to work on the pages themselves. Right now we have about half of the page functionality done. What we need to do next is put some kind of button that can send that data to the server. We'll do it old school and wrap the elements in a form. This will make it easier for the browsers to tell that the page is a login or a registration page. Now that we've created an input submit element and wrapped it in a form, we can try out its post functionality. Whereas without that, it would have just set the query parameters in the URL as we've shown previously. The post method would send the data in the request body. The fact that it is a post request as opposed to a GET request is especially important, as we can root on that specifically. We'll check whether the request method is post, then check the path, and then pass that through into web combinators that handles the login and registration functionality specifically. In the web combinators, what we will do in both cases is deserialize submission data in the request body from the form format into an F# record and use that to create a cookie for the user. For now, we are just sketching things out and won't be storing the data in a database. We'll gradually build up to an in-memory one, and then a real one as we go along. Right now, let us get the data extraction functionality out of the way. We are making good progress. We now know how to send post requests from the client and deserialize them into .NET objects that we can use on the server side. We even return in user page after a successful login. But returning in user page only works because we are returning the HTML view from the register handler directly, which already has the user data. We aren't redirecting the user to a different page that is on the site. In order to be able to implement that, we need to be able to extract the user data from somewhere. As HTTP requests are stateless, we can only get that data from the request itself. When a user makes a request, he should also be sending his user credentials inside the cookie. Those credentials are the very ones we are creating during the registration here. What we have to do is just set the cookie in the response header that we send back to the client, and he will be sending them to the server on every request thereafter. at least until he closes the browser and the cookie is wiped. As our next assignment, how about we play around with the cookies for a while in order to get familiar how they can be used to pass around information. How about we try putting the registration data from the handler into a cookie and then extract it and make use of it in the user page? Let's do that next. As you'll see, ASP.NET has good functionality for dealing with these kinds of cases. Enjoying the music? At any rate, by now we should have a grasp on how to set and get cookies in ASP.NET. We've demonstrated how easy it is to serialize and deserialize them. But obviously, in a real-world scenario, passing raw JSON like this would be a security problem. So what we have to do next is introduce some form of data protection. Like in that Python web development course that we linked to, we could try encrypting the cookie by hand ourselves, but ASP.NET offers a wide variety of libraries for that kind of purpose, from the low-level primitives that you see on the screen here, to middleware specifically designed to encrypt and decrypt, as well as get and set the cookies for you. In this video, we aren't interested in how to use the ASP.NET cryptographic APIs directly, so we will skip to the middle level, which is the authentication middleware that is built on top of it. We'll leave the ASP.NET Core identity for last. We've covered a lot of the basics, so finally, let us get started with authentication. We'll start with the registration handler and make our way from there. In order to be able to access the authentication middleware using the context, first, we need to bring it into scope. Opening the authentication middleware should also extend the HTTP context with the methods that we need. As much as we'd like to just plug in the data directly, we need to follow the framework conventions and create the claims principal so we can pass it into the sign-in async. Remember how we said that the claims principal has identities which have claims? We need to make all of those here. So right now, we are working on this and wondering, where should we put the password? Moreover, if you hover over the claim types, you'll see these weird HTTP addresses. What do they mean? Why do these claims exist? Let us take this opportunity to reinforce what authorization means, because you might still be holding misconceptions as to what should go into the cookie. We need to reinforce the notion of what having a cookie means. Because the cookie is only created after a successful login or registration, and because only the server can decrypt and verify it, the cookie's existence itself serves as proof of a successful login in the past. And if it was good in the past, it is good in the present. There is no need to check the database using the cookie information. So the cookie doesn't need us to put any claims in it. The claims are just an extra to make the server's work easier. You'll see in a later lecture when we talk about JWT tokens, how claims are actually not even encrypted in those particular kinds of tokens. So what goes into the claims should only be information you wouldn't mind going out in public. For that reason, you definitely don't want passwords to be a part of the claims. With that understanding in mind, let's create the claims principal and give it a run. After that, we'll bring in a database. We forgot to mention, those weird URLs in the claim types don't mean anything specifically, and you can put any kind of string in there, but the known claim types will get assigned to properties in the claims principal. More specifically, just the name and the role claims, which we aren't using here. Now that we have the claims principal set up during sign-in, let us show how to make use of it inside the user page. This should be good enough. Let's try running it and we'll see whether user page still works. It took some wrangling, but we got the user logins to work. You've seen how if we tried to enter the user page without the necessary cookie, it would have redirected us to the login page. Right now the login page is not very useful, but it will be once we add a database. We'll work on that next. For this next part, we are going to have to install Entity Framework Core in order to access the database. It is very convenient as it abstracts over the different kinds of databases we can use, and under the hood it will translate the link statements to SQL. This will allow us to use whatever database we need in a fairly functional manner, as if we were manipulating regular .NET collections. Entity Framework has various adapters for the different kinds of databases, and we'll also need one for the in-memory database as well. We are missing a name argument here. We can name it anything, so we might as well go with SimpleDB. Incidentally, the ASP.NET Core docs recommend not using the in-memory database for either testing or production use, but it should be fine for this demonstration purpose. Now that we've added it to the service dictionary successfully, we'll be able to access it from inside the context. But right now the type we defined doesn't have anything inside it, so we need to add a database set for the user data that we are using. And now that we have a DB set inside our database context, nothing can stop us from finishing the authentication demo. Let's take care of the login and register handlers, each in turn. If we were writing regular C#, we'd use dependency injection into class constructors, but in F#, we should just get the service directly. After that, we'll be able to access the user's records through the database context. Then we just have to check for duplicates and take care of the true and false case. In the true case, we'll create a new database record by adding it to the database. In order to have the changes be applied, we need to save the database. And in order to not run into concurrency issues, we need to do an await immediately. This was the longest video we've put out so far. If you found it useful or informative and want to reward us for our hard work, click that like and subscribe button. I'd say we've earned it. We'll make this part 1, and in part 2 we'll build on what we've done so far and simplify it by using ASP.NET Core Identity. We'll also show how to replace the in-memory database with SQLite and SQL Server ones. We'll probably have time to also cover the use of JWT tokens and maybe even third-party authentication. We'll see how it goes. For now, let us close here. This has been Vilo, and you've been watching Ghostlike's channel. Stay in good health, and we will see you soon.